This is the second part of the video, AC through pure capacitance. In this video, I will show you the phasor diagram when I will apply an alternating voltage V equal to Vm sin omega t or omega t plus 0 degree in a pure capacitance. After that, I will calculate the instantaneous power, from which I will derive the equation of average power that will be absorbed by the pure capacitor. See here, I will apply V equal to Vm sin omega t plus 0 degree. To draw the phasor diagram, at first I have to write this equation in phasor form. Therefore, I will take the amplitude Vm and initial angle 0 degree. In a pure capacitor, our alternating current I is equal to Im sin omega t plus 90 degree. Therefore, I will take the phasor I equal to maximum value of the alternating quantity, and I will take the phase angle. Phase angle will be 90 degree. Therefore, this will be our voltage phasor V equal to Vm, phase angle will be 0 degree, and this will be our current phasor I equal to Im, phase angle 90 degree. When we have a pure resistor or inductor or capacitor in a circuit in which we will apply this sinusoidal voltage, usually we take the positive x-axis as our reference. Okay, therefore, if I want to draw the voltage phasor, you will see it will have magnitude of Vm and it will create 0 degree angle with the reference axis. That means the alternating voltage or the voltage phasor will go in the direction of positive x-axis and it creates 0 degree angle. Okay, now look at the current phasor. Here you will see current phasor has a magnitude of Im and a phase angle of plus 90 degree. Plus 90 degree, that means I have to rotate in counterclockwise direction if I want to draw the current phasor. Okay, so to draw the current phasor, I have to rotate by an angle of 90 degree from the reference axis. So this axis will represent our current phasor I, and it creates an angle plus 90 degree because I am revolving in counterclockwise direction. And here you will see, as this is our reference axis, with respect to this axis, if I want to go into the current phasor, I have to rotate by an angle of 90 degree in counterclockwise direction. That means the phase difference between V and I will be equal to 90 degree. And you will see our current phasor I will lead the voltage phasor by an amount of 90 degree, or our voltage phasor V lags current phasor by an amount of 90 degree. Okay, now let me show you how do we calculate the instantaneous power. The instantaneous power P will be the multiplication of instantaneous voltage and instantaneous current. P equal to V I. Here our instantaneous voltage is given by Vm sin omega t, and our instantaneous current is given by Im sin omega t plus 90 degree. Sin omega t plus 90 degree, that means it is given as cosine omega t. See here, I have Vm Im sin omega t multiplied with cosine omega t. There is a formula, sin 2 theta equal to 2 sin theta cos theta. So here if I take Vm Im by 2 and multiply that with 2 sine omega t cosine omega t. There you will see I will get the instantaneous power Vm Im by 2 into sine 2 omega t. This is the equation of our instantaneous power small p. Now I will calculate the average power absorbed by the capacitance C. See, I will calculate absorbed power. That means P average will be the average value of Vm Im by 2 sine twice omega t. Here sine 2 omega t. That means within twice pi interval it will complete 2 complete cycles. Okay, we will calculate its average value. See, we calculate the average value of any alternating waveform by taking the area under the curve over full cycle. Here I will consider twice pi interval, area of curve over twice pi interval, and I will divide that with the period. That means here I will consider twice pi interval, period will be twice phi. Now if I draw the waveform of the instantaneous power, I will get an waveform like this. This will be our instantaneous power. This will be phi, this will be twice phi interval. In the x-axis I will have omega t. Now see, the maximum value of this sine 2 omega t will be Vm Im by 2. This is 0, and the minimum value or the negative maximum value will be minus Vm Im by 2. Okay, now see, how do we calculate the area of this 2 sine omega t over twice pi interval? I will simply integrate it within 0 to twice phi interval. Magnitude will be Vm Im by 2 sine 2 omega t d of omega t divided by twice phi. Now see, within twice phi interval I will have 2 positive half cycles and 2 negative half cycles, and the area of the positive half cycles will be cancelled out by the area of the negative half cycles. Therefore the area covered by the instantaneous power will be equal to 0, because positive and negative areas are equal. So integration of Vm Im by 2 sine 2 omega t d omega t within 0 to twice pi interval will be equal to 0. 0 by twice pi will be equal to 0. That means the average value of the power absorbed by the capacitor will be equal to 0 watt. This implies that our capacitor will not absorb any power. During positive half cycle, the power is being absorbed from the supply or source, and in the next half cycle, that means during negative half cycle, it returns, or the capacitor returns the power to the supply. This is how it will not absorb any power from the source. Rather, our capacitor stores electrical energy in the form of electrostatic energy or in the form of charges. Therefore, you will see, if I know the value of voltage across the capacitor, let's say the voltage is V, the energy stored in the capacitor will be half CV square. Okay, that's it. Thank you.